project being presented is demonstrating multi-fluidic control of a remote operated vehicle, or ROV. We are creating a thrust vectoring drone that can operate in air and water and transition between the two mediums. Here you can see the front side of our ROV design that we decided to go up with. You'll notice the different electronic components mounted on the outsides, and you'll notice that on physical we have all the wires that are hooking up all of these different electrical components together. One of the biggest things that you can see around here is our flight controller. This is in charge of communication protocols on the ROV. So our application for this ROV would actually be for a search and rescue application. For example, this Francis Scott Key Bridge went down around the time when we first proposed this project. Hopefully we would want a final design with a camera that would be mounted on this location that you see pointed in the video. Currently our prototype would have no camera. Now here you can see the back side of our ROV. And then now next we'll talk about the big most important component, which is the EDF, or the electric ducted fan. That is what's situated at the top of the ROV and is what provides thrust to the whole platform. Up next we have our batteries that you see there. Obviously, in order to power these EDF to provide the thrust that we need sufficiently, we need some pretty powerful batteries. We use two 6S batteries, and they will be wired in series so that they can combine and provide more power for us to have longer run times. So here our ESC, which stands for electric speed controller. It commands the speed that will be sent from the flight controller to the motor. Up next, we have a power distribution board. This transmits power to the ESC and also the servos, as well as the flight controller. Next, another big component are the servos. These servos were waterproof servos that we ordered in order to not have to redesign a new servo. So we've tested them in underwater, so they do work as well. But this will be important for us when we're trying to transition between air and water. There are 4 servos, and they work to control the pitch and roll of the ROV, and that's what lets us maneuver in the air. Here we have the flaps. These flaps are what actually change the direction of the thrust that's coming out of the ROV. So by changing the direction of the thrust, that's how we quote-unquote thrust vector. So we can just change the direction that the vehicle is going in. Here's the initial render of our drone flying rigidly in the air. It's an ideal representation of what our drone looks like flying. And next, this is how we plan to transition our drone from a flying state to submerging underwater. Thank you for watching our video.